In this video, I'm going to talk 4.5 from the book, okay? Chapter 4, section 5, which is the last section from the book. It is integration by substitution method, okay? So far, we learned some of the formula for the antiderivative or the integration, right? For example, we learned x to the n, the antiderivative is x to the n plus 1 over n plus 1 plus c. Cosine x dx is sine x plus c, and so many other formula that we learned, right? By using the inverse or the reverse process of the derivative. Now we will do some more, we'll study some more method or the techniques or the formula of the antiderivative. For example, none of the formula will help you to do this integration, because you see that there is the product. You see that? It is x squared plus 1 to the 1/2 times 2x. If it was just 2 instead of 1/2, you would FOIL that, right? You would write x squared plus 1 and then parenthesis and then another parenthesis x squared plus 1, and then you would FOIL. And then finally you would multiply with 2x and then you would integrate. But there is 1/2, which is the root, so you cannot FOIL this easily, right? So how do I do this type of integration? Okay, so the substitution method is a very useful and important techniques, and very simple, very basic and very important and useful technique to do the integration. Okay, so what is the substitution method? Is usually if the problem has a product or sometimes the quotient. You see that there is a quotient here, there is the quotient here. In that case, what we do is we usually assume that the complicated form. What does that mean? That means 2x is just simple 2x, right? But here you have x squared plus 1 to the 1/2. That is the harder term to integrate, right? Usually what we do is you take that thing under the inside the parenthesis without the exponent. Just take that as u. What we do is you let x squared plus 1 equals to u. So what we are trying to do is we are trying to change all these x into u's, because see, after you substitute that, what do you get? Let me denote that by I. I is the integral, okay? This integral I denote by I. So I can be written as, since when you replace x squared plus 1 by u, then this will become u to the 1/2, right? So this thing changed to u. Again, when you set u, don't take that 1/2 without the exponent, just the things inside the parenthesis, okay? Take that as u. Now, how about this 2x and dx? What happens to this 2x and dx? How do I write this in terms of u? That is the next thing, okay? So what should I do for that is find the derivative on both sides. What do you get? If you find the derivative, then you will get 2x equals to du over dx. You see that? I'm finding the derivative on both sides with respect to x. Now this can be written as, you can think of like this. There is like cross multiplication type of thing. It is basically finding the differential, okay? So you can write du equals to, do you remember that if y equals to f of x, then what is y prime, or what is dy? Just the differential, right? F prime of x times the dx, right? You can think that way. What is the du here then? So the du is basically 2x dx, right? 2x dx. So for this term, 2x dx, you can just write du. Now you see that this integral is very easy to integrate now. How do you do that? It's basically u to the 1/2 plus 1 over 1/2 plus 1 plus c. You understand? And this is equals to, so u to the 3/2 over 3/2 plus c, right? Because plus c is default in the indefinite integral. What do you mean by indefinite integral? If there is no limits of integration, then you always write plus c at the end, okay? So this can be written as 2/3 u to the 3/2 plus c. This is not the final answer. Why? Because our question was in terms of x. So you need to replace back the value of u. So the final answer will be 2/3. What was our value of u? X squared plus 1 and then 3/2 plus c. This is the final answer. So the idea is the complicated term without the exponent, the complicated term that has some exponent, some fractional exponent, or any other that type of thing, the thing inside the parenthesis, you denote that by u, and then you find out the derivative or find the differential. Okay, so find out the differential. What you get is du equals to the derivative of that and then times dx, and you replace that by u and then that thing by du. Okay, and then you just use the regular integration techniques, but don't forget to plug in back. All right, let us do this example. So how do I do this problem here is, look at this. This is x times, right, 2x squared plus 5 to the 9. You see that? So how do I do this problem? Is again the substitution, because the general these type of rules, it doesn't work. I mean, it is hard to expand that x that thing to the 9, right? Because it is like 2x squared plus 5 and then 2x squared plus 5 times 2x squared plus 5 9 times. You don't want to do that way because it is too complicated, too long, right? So what you do is you substitute u. Okay, so solution. So what should be u then? Let this is the complicated term, right? So I will set this thing equals to u without the exponent, just that thing, base thing as equals to u. Let's say 2x squared plus 5 equals to u. So what we did is we substitute that by u, but what we have is we still have x times dx left. So how do I write that in terms of u is find the differential, right? So what is the derivative of this with respect to x? It is like 4x equals to du over dx, right? So you can write this implies du equals to 4x dx. So what is left here is this is x and then dx, right? We don't need the value of 4x dx. We need the value of x times dx. What is the value of x times dx? Divide by 4 on both sides. You will get, this implies x dx can be written as 1/4 du. You understand that? So here, when you find the derivative, we got exactly what we needed. 2x dx is du, right? But here we needed x times dx, but when you find out the derivative, you got 4x dx is du. So you need to find out the value of x dx because that's what we are needing here. You understand? So x dx equals to 1/4 du. So what I do is, let us denote that by I, the integral. Therefore, the integral I is equals to, so this is u to the 9 times x times dx is basically 1/4 du. You see that? Now this 1/4 is a number, a constant. I can pull that out, 1/4, and integral of u to the 9 and then du, right? Since u and u match, then now you can use the power rule. So it is 1/4 u to the 10 over 10. You understand that? Plus c. So this is not the final answer because you need to plug in back that u value. So it will be 1/40, and then you write 2x squared plus 5 to the 10 plus c. That is the final answer. It is pretty easy method once you know it, right? But you need to, the first thing is what should be u. That is the very important thing, okay? And after you do a couple more examples, you will know what should be u to do this, to do the problem, okay guys? So let us do this. So what do you think? What should be u? What should be u? You're right. So that must be u, right? That is the complicated form that has power. So let's do 4 minus x squared equals to u. Or you can write u equals to 4 minus x squared, right? So that is exactly the same thing, no problem. So what you do is, how could you write that then? So negative 2x dx is equals to what? Du? Because when you find out the derivative, you will get negative 2x equals to du over dx, right? And then I multiply, you can think of like what will be du? Du will be the derivative f prime of x times dx, right? That's what we were using here. Okay. But what do we need here is we need 7x dx, the value of 7x dx. But we found the value of 2x dx. This is not what we need. We need 7x times dx, right? So how do I do that? I will write x dx equals to negative 1/2 du. What did I do? I divided by negative 2 on both sides. Now I multiply by 7. So 7x dx equals to negative 7 half du. That's what I got. So the value of 7x dx will be negative 7 half du, and this is u to the third. Therefore, the integral I assume the whole thing as I, integral. I denoted that by that. So integral of that, now 7x dx is negative 7 half du. You understand that? Divide by u to the third. Right? Let me pull that number out. Negative 7 half, and then 1 over u to the cubed, and then du. You can write that way, correct? So this is written as negative 7 half. Let me do that thing. And then integral u to the negative 3. This is how I find out the antiderivative, right? Du. So how much is that? This becomes negative 7 half, and then u to the negative 3 plus 1 over negative 3 plus 1 plus c. So how do I write that? This is negative 3 plus 1 is negative 2, right? Negative 2, and then negative 7 half will be positive 7 over 4. And u to the negative 2, right? So you can write plus c. So you can write this as 7 over 4u squared plus c. You understand that? Now plug in back the value of u. You will get 7 over 4 and then 4 minus x squared to the cubed, and then plus, not cubed, square, right? Because u is squared. So this should be square. Okay, let me write that square plus c. That is the final answer. 7 over 4 times 4 minus x squared to the square plus c.